Hey, we have Monte, Mabry, and Belleau. We're going to be hearing from two fellows that between them, have 80 years of flying experience and 40 plus years of mechanical experience and all kinds of credits. And they've been involved in a lot of stuff. And so let me just pass it on to you and let you go.
Thank you for the opportunity. At Cornfield, I plan to take produce this presentation. I had an issue, so he was able to voice it off on me. I'll do the best I can. My quest is to never tell you a lie. That's the key. If I get it to work. Okay. Flow plane maintenance and pre-flight items. Many of you, I'm sure, do a very thorough pre-flight. Some of you may do a little less thorough pre-flight. There's a spectrum there. And it's on the quality of your airplane, whether it's parked in an area where you've got it well secured. My spot over on Lake Hood, pretty notorious for, I'm not sure the technical term for them, but folks that wander around and play with airplanes. So I've shown up and guys in the airplane, they were taking pictures. So yeah, you just never know. So I'm a pretty thorough kind of pre-flight guy. I'm A&P, so I tend to give a pretty thorough one. One thing I always do is my pre-flight is always exactly the same pattern. I don't change it. I've got a system. I always do the same pre-flight. It starts in the same spot. I always go the same rotation. I do things in the same order. My cockpit pre-flight, same thing. Get in the airplane. Before I untie it, I go through, I get it set up. Got my radio set on the frequency. I got the fuel selector on. I do everything in the same order every time. I do that because I'm not a very sharp guy. I don't freelance well. So I have my pattern. I've developed it over the years. I always follow the same pattern. So that's my pre-flight trick. Okay. Not exactly a great photo, but they're basic floats. Water rudders at the back. Bumper at the bow. Hopefully you don't use the bumper that frequently, but it's there for you. And the whole body. Like I said, not a very good photo. It's much better on the screen, the small screen, but.
That's better.
That's better.
You can read that.
Not sure what I did there. Yeah, there you go. Handhold covers. The old Edos had the round ones. Originally, the Edos did not have pump outs, so you pop the cover off, reach in there with your little coffee cup, throw the water out. We came up with the pump out systems. Those were actually added. Most of your small Edos that were built back in the 50s, early 60s, the pump outs were added in the field. Water rudders at the back, real critical. Steg there. If you beach tailing the airplane up, that's an area that gets damaged up right there because it's the part that hits. If you're on some bigger rocks, it'll tend to get damaged at a step. You'll punch holes in there. It's also the hardest part to fix on a set of floats. It's down in the corners, the furthest away from the top of the airplane or the float, and it's fiddly corners, so the patches are really hard to make. So be careful when you're dragging an airplane up on the beach to beach it. That's a good place to do some damage. Last thing you want to do is damage your floats out there. Have to deal with it. Field patch, bring it back, and then spend some more money getting in there and fix it. So watch that area. That's what we got here. All right, the water rudders. Now, if you look, water rudders got a hinge line there. You can see the hinge. Basically where it pivots on that tube, retract the water rudder, and it flips up out of the water. You don't want to land with the water rudders down because they'll flip up and they'll damage other stuff. stepping into the Monte's little neighborhood, if you're in a tough blow in a tight area, you're taking off, and you're having trouble keeping it steering, you can leave the water rudders down till you get going, because the water will push the water rudder out of the way, but it won't be a rapid snap, it'll be gentle. So that's a little technique, a little tool, have a toolbox. If you're having trouble with your directional, leave the water rudders down until you get the air rudder flying, and then you'll be able to fly out here. Note that there's surface area forward of the hinge, surface area back. Real common, folks go, floats aren't beyond, I'm having trouble steering this thing. So they'll get their mechanic to build bigger water rudders. It's very common. Remember that you gotta add a little bit at the front. This is kind of like a balanced elevator or a balanced rudder, power steering. If you just put it on the back, you're gonna add load on the rudder system, and you won't have as much area forward to reduce the loads in the system. All of your water rudder systems have a spring, so if the water rudder jams, your air rudder will still be able to be utilized. Western Alaska, I worked out in Bristol Bay for a while. We would safety wire up the water rudder springs for the pilots. Now remember, these are professional pilots. We're working really high winds. They're flying days where you or I wouldn't even want to think about going out there. That's just another day. They gotta go make some living. I suggest you do not safety wire your steering spring. You want that thing to stretch if you need it. And if you're having trouble taxiing that airplane because of the winds, because your water rudder springs are stretching, maybe you ought to not be trying to do what you're trying to do. My dad was an old goose pilot up here, and he used to say, if you're having trouble, turning into the wind, or turning downwind rather, the airplane's telling you that the winds are too high for you to be turning downwind. Sail the airplane back. So that's that. These systems have a spring that pushes the water rudder down and forward into the water. The springs get old or they'll get broken. Edo gets a lot of money for these things. All the manufacturers usually charge a lot for the springs. So I'll just go over to the hardware store and get me a spring. That spring pushes the water rudder down and gets it aligned on the hinge point. If you don't have that, then it's trailing back. Now again, we've got all that surface area to the back, nothing in the front, and so you step on the rudder pedal, and the water rudder doesn't want to do anything because it doesn't have its power steering, it doesn't have its counterbalance its head. So that spring is critical. Some have two springs. Having the correct spring and making sure that the pivots are free to pivot, that's all critical on that. So keep an eye on that. When you're doing your pre-flight, watch out for broken springs, things like that. Loose pivots, that's another thing to watch out for. Okay, here we are retracted. You want to make sure it goes all the way up. But if you notice, now we've got all the surface areas to the back, so that water rudder will act as a trim tab. You first put your airplane on floats. If it flew flying, hands-free, wings level, without having to step on the ball on wheels, when you put it on floats, suddenly the ball's off to the side. Some folks will go, if you're a 185 or late 180, you got a rudder trim, but the Cubs, early 180s, they don't have rudder trim. So your mechanic is, I need you to go tweak the rudder tab on that. Well, I suggest you don't. And the reason is that airplane flew fine. This water rudder can be used as a trim tab. So what I'll do when I set up, I'll set the air rudder off to the right just a little bit, and I'll streamline the water rudder. And so in flight, the water rudder streamlines, and now my air rudder's got a little more right rudder. And on floats, because of the drag, you're You're gonna have the nose up a little higher deck angle, so it's gonna change the trim on the airplane. So that's a simple way to do that, and you can dial it in, because you usually have some turnbuckles back there on the water rudder. You can just dial it in and get it really nice, and you won't mess up your land plane trim, and then in the fall, go on wheels, and then start bending that tip back and forth. So that's my little trick there. Another picture of water rudder, you can see when it's down, hanging forward. Also, you've got two horns up top. Gotta watch those. You beach the airplane, your passenger, your kids, family, friend, they'll step on that because it's at the very end of the float. You know, that's the last step onto the beach. Try to educate them, keep an eye on it, make sure that they're not stepping on that. That would cause some damage. Always, when I'm doing my pre-flight, not only do I look at stuff, but I feel it. I'll wiggle it around a little bit. Always check the bottom for the cotter pin, make sure the cotter pin hasn't corroded off. Occasionally they'll do that. So feel around, double check all your cotter pins. Make sure the water rudder goes all the way down and swings all the way forward. Here you got a spray rail there. Some aircraft or some of the floats had spray rails from the factory. A lot of them were not, and they were added either as a service kit or we just put them on. Spray rails do a couple of things for you. One, they keep the spray off the prop. There's some folks that they provide a little bit of lift. You know, the jury's still out on those. One thing they do love to do is get wanked on stuff. So if you're beaching going forward, or you're working with the dock, next thing you know, you got your spray rails all torn up. Also, the float truck guys like to hit them. A lot of the spray rails started out 4 inches. Next thing you know, somebody's got a 6-inch one. Our culture is if a little's good, a lot more, much must be better. Avoid that. You increase the lever arm, and now you start damaging the chine on the float there, and you cause some grief there. Also, if it's not sealed tight where it meets the float, if there's a gap there, what'll happen is instead of having the water go up off the curved portion of the float, it'll work like a little jet, and it'll just spray that water up in there in the prop. So make sure there's no gaps in there, because it'll defeat the purpose of having it on there. Float wires, sprayer boxing wires, some folks refer to the others as fly wires. Anywhere they cross, they tend to rub. The box wires are not as bad because they're parallel to each other, and they generally don't hit real hard. The flying wires, where they cross, tend to hit real hard. So sometimes you put a little plastic washer in there, or somebody will put a phenolic one, or you wrap it with a piece of rubber or something like that to keep it from chewing up the neighbor. Also, when they were factory new, there was a little round section, because they're streamlined, there was a round section where they crossed. Well, over the years, the float wires get damaged. Now we go buy another set. We may not be able to get exactly the correct set, so we get one where the round portion is not quite the right spot. Gotta watch out for that. Watch for any damage. These are highly stressed. They're stainless steel. Stainless does not like, it fatigues faster than mild steel. So it's not very fatigue resistant. You get yourself a little nick in there. It's a stress riser. My engineering friends can give you all the math, the physics on it. The metallurgist will tell you a lot, but nicks cause stress risers, which cause them to break. They're expensive, and you don't want to have a busted one, so it can cause you some troubles there. So watch those, watch for chafing, Watch for, a lot of times the old ones used zinc-plated turnbuckles, ends or end float fitting ends. They'll corrode the stainless steel right where the threads meet, because you have dissimilar metals. Even though they're both steel, they are dissimilar, and they will tend to corrode in there. So watch that. Watch your float wires. Check those out every time. Water rudder pulleys, cables. Always make sure the pulleys are free. I always give them a little twist, make sure they're free to turn. Watch your cables for frays. Traditionally, they fray wherever they go through a pulley. It's going to have some change of direction. They'll tend to fail there. You also got a water, float inspection panel. Those can get loose. There's also on the round ones a rubber grommet. Those will get weather checked, and you'll start getting water through those. Watch for that. Make sure that they're tight. The nice thing is, big screwdriver, those come off real easy. You can look inside the float, see if you've got anything in there. If it's leaking, it's you check the openings, put it back in. AC 4313 1B, that's the standard for aircraft inspection, repair, and alteration for any aircraft that doesn't have an existing instruction for continuing airworthiness. Almost all of our floats, the older floats, the old EOs, they had very little information published for maintenance. It was all done out of 43. If you want to find any information, EDO did publish maintenance manuals for the amphib. So you go find the amphib that was of the same circa or design. What was it? There was a 29, there was a round top amphib. It's got a manual. It's going to be applicable to your 2870s, 2960s. They had the flat, I think they were 3400. That would be applicable to like your 3450s. So you could go to that for some guidance, and it would have some information, more than nothing. Again, 4313 is it's approved data for aircraft that don't have an ICA. It's acceptable data for minor repairs for, again, aircraft that don't have ICAs. And it's got a section on, and it's available online. You can go look it up. It's got a section on inspecting your wire, your float cables. They're usually 3/32. They're fairly lightweight, so they're not real damage tolerant. So pretty much, there's a guidance that lets you have a couple of broken strands. I forget how many it is. My rule is if you have one broken strand that you can see, there are more that you can't. So if you've got broken strands, I would replace the cable or splice in a new section. And again, there's some more wear stuff. Generally, the stainless steel cables are not as strong as galvanized, and they tend to fatigue fail faster. They also wear faster. They're a softer material. They don't corrode, but they are a softer material. But there's some external wear patterns that you might see. Again, I think you're allowed up to 50%. Generally, by the time you get 50%, you've got some broken strands. You've got one broken strand. If you take that cable loose and fold it open, it'll look like a little rooster's head. I mean, they just splay up there. So what you see is a fraction of what you got. A little less for you as a pilot, but the standard repair schemes in 43, any of those are acceptable, again, unless there's an ICA. Whipline floats have an ICA. They're pretty good about that. They've got specific repairs. And of course, how to buck or rivet. Again, and threw this in here, traditionally on float repairs, anything below the water line, we overbuck the rivet. not sure why, but that's what I was taught. We, instead of going for a 50% D, half D height, we'll usually go under that, probably closer to 40%. Earlier, we talked about, John Pratt talked about looking at your gear castings. Again, we go in on and off of floats. We pull that on the Cessnas, we pull out the wheel plane gear. We put a little, commonly called a pork chop or a stub gear in there to attach the floats to. Critical that you replace the inboard bolts. We go back on wheels, that's my suggestion. That inboard bolt tends to take the vast majority of the load. It's in tension, unless you've got the P-pump kit, which there's some debate about that. I won't go into it, but some folks like them, some folks don't. Also the little wedges. Let's see if I can get them here. So you got the little wedges. So you put your vertical bolt on the inboard end, right there. And then you have these little wedges that you tap into the gear casting. The wedges are there to keep the gear from bouncing up and down. You don't need to pound them in really hard. They're tapped in. I've seen guys get in there with a 5-pound mallet thinking that they're making things good. What they're really doing is they are stressing this little casting, them cracking the corners. So you see your mechanic pounding those wedges in. That's the wedge right there. That's not good. They don't need to. There's a bolt that holds them to keep them from rattling out. So snug is all they really need. They don't need to be hammered in there. Again, this bolt here is in tension. That nut is also in tension. Former life, I worked up at Air Glass Engineering, landed skis, and I did TSO tests on quite a few skis, some new designs. A bolt in tension, actually the ones down here, that was the weak point on all of our hydraulic wheel skis, was this, what the bolts held that axle on. What we found was a full metal locking nut was about 30% stronger than any of the other nuts. A lot of folks think that the little, what we commonly call missile nut, is real strong. It is actually not. It's light, but it is not strong. A full height metal lock nut is the strongest one. We got about 30% more load before it hits the threads. In particular, these, and because of the way the tests were done, it was the rear two bolts that stripped out. So make sure your mechanic is using a full height metal lock nut, and not a missile nut, not a nylock nut, something like that. Personal opinion. Most of your Cessnas that have been ground looped, that bolt fails. The gear comes out. I'll go into the P-pump. Really nice, it will capture that bolt and it's less likely to fail because now it's just in shear instead of in shear and tension. The flip side, the argument against it is if the gear wants to come out, it comes out with this system. If the gear wants to come out with this system, it takes the side of the fuselage with it and the repair bill is higher. But again, it's a debate and I won't go into that too much. Here's our standard CAD plated bolt, although I am told they are no longer CAD plated, they are zinc plated bolts. Generally on that Cessna gearbox, when it fails, it pops the head here off. But again, if you got the wrong nut, this will strip out as well. Fatigue failure, it pops the head off. Ed was smart. He and I must have gone to the same school. Nylock nut, lovely, perfect for most utilization. Again, not quite as strong as a full height metal locking. Also, You can reuse them, however, there's what they call a minimum prevailing torque. If you don't have that, the lock feature has worn out. So you reuse them, but you want to make sure that there's drag. The common field trick is if you can screw it on past the nylon with your fingers, it's worn out, so you get a new nut. Here's the full height steel. And again, what happens is the locking feature still has thread engagement and it's got structure there, so that's why they're stronger. It's pretty simple. I know this was billed as a Seaplane seminar, but Ed wanted to get into the tail wheels. A lot of tail wheels do not get a lot of attention. They're very fiddly. They've got a lot of little moving parts. A lot of parts wear out. Scott tail wheels, which was common to most of the aircraft. There's a few PMA versions of it now that you can get. One of the odd things was Scott rarely marked the actual parts. And while they look very similar, they are not. And so the order of assembly is critical. And the order of disassembly relies on the last person putting it together correctly. So a little bit of stuff to worry about. You've got these tension springs that you can add additional ones. They will kind of reduce shimmy. So if you've got too much shimmy, you'll add a spring. You can also tighten this bolt on most of them. You can tighten that. That will give you a little bit of tension addition. You can add springs, reduce the shimmy. This pawl releases the tail wheel, allows it to full swivel. So when you stop on the brake and it swivels around, if you put it in upside down, it will jam against the phenolic washer and it will lock the tail wheel up in a turn. So that's something to watch out for. So that's critical that you get it in the correct direction. It rides against this little spring. What it does is when you get to a certain point, this spring is depressed inward. There are some grooves in the steering arm, and it allows it to swivel to that side. The spring will get chewed up. They'll get worn. And they won't actuate properly. Also, the groove in the steering arm will get worn out, so it'll slip on you. This bushing is for the Scott 3200s, used mostly on the Super Cubs. The Cessna 170s also use that bushing. It's a bronze bushing. It wears out. When it wears out, mechanic jacks the tail wheel up, actuates just lovely, perfect. Put the weight of the airplane on it. This bolt here will rotate, the fork will shift aft, and it will pinch some of this stuff on the back side. Airplane doesn't steer as easily. If you find yourself having to tap a brake to start the turn, then tap the other brake to stop the turn, chances are this bushing is worn out. You won't see it when it's sitting on the jack playing around, but when you're taxiing, you have to always tap a brake to start the turn, tap another brake to straighten it back out. Likely this bushing is worn out. When things are really getting nasty, you can't steer, and now you're off in the bushes. The 170s are more likely to damage that because they got a higher weight on the tail. The Cubs less so, but that bushing, they're like $14, so it's not a bad thing to change once in a while. At the very least, keep an eye on it. The 185s, heavier aircraft, instead of that bushing, they got a bearing at the bottom. They've got a bushing at the top, so they don't have that problem. Basic setup is similar. This one's got a locking feature. Some of the 180s had a locking feature at high gross weights. They would tend to shimmy, so they had a lock that you could swing, and it would lock the tail wheel straight ahead. fairly nice little system, fairly fiddly, has a cable that's, I don't know, 280 inches long, frequently corroded in there, don't want to actuate very well. ACF 50 on control cables is phenomenal. It will, on those push-pull control cables, that loosen those up. I used to work on Gooses, and all the little control cables out to the engine, we would occasionally peel them out, throw them in a 5-gallon bucket, pour ACF 50 in there overnight, next day put them back in. My gosh, they were like greased. It was just phenomenal. But, so anyway, again, these are very fiddly, there's a lot of stuff. There's no part markings on any of them, so you have to be cautious when you take them apart, put them back together. That one's really not worth looking at. Plastic wheel, PMAs, virtually everything, so the stuff's readily available in town. Float plane pilot suggestions and techniques. I'm a private pilot. I fly for fun. My dad was a 30,000-hour goose pilot. All but about 800 hours was in Alaska. So he knew a lot. I was a slow learner, so I didn't pick up much. But Monte here, he's a very experienced pilot, seaplane pilot. I'm going to turn this part over to Monte.
Can everyone hear me okay?
Yeah.
How are we doing on time? We're good.
You're the last speaker, you take as much.
Okay, well, Ed Cornfield was originally slated to do this presentation. He's back east taking care of some family things, so I just flew in this morning naturally, and I've kind of been thinking about it, so I'll do the best I can. Ed put together a series of pictures, and when I talked to him, the pictures don't necessarily correlate with the bullet points. So, but regardless, I think you'd rather look at the float plane pictures than look at me. So I'm going to go through a series of ideas. No matter how much experience you have doing this, you always have to guard against things like complacency or thinking, oh, I've done that 1,000 times before. Every flight is different. I've never had 2 flights exactly alike. I've had some that are very close. That's one thing that keeps aviation and flying these small float planes fun. One thing on floats that I see a lot of like good is people skimp on the pre-flight. They think, oh, I just push off the dock. I was the last one to fly my plane. Always look at the plane. You just never quite know. It's just as important as wheels. It's harder to do a good pre-flight if you really, sometimes you have to actually flip the plane around where you can see both sides of it. But there are a couple of nice things about float planes, the way it's sitting in the water, as long as it's off the beach or off the dock. You can take one look at it and you can tell, oh, I've got a leaky float compartment. It's not sitting quite right. Things like that. But make sure you do the usual pre-flight, just as you would do on wheels, your fuel, your oil, that type of thing. And also your CG for float planes is a much smaller range than wheels. So make sure you have the right CG chart for a float plane. In something like a 206, it's quite different, and usually it's more restrictive. So if you're out of CG on a float plane, it won't come on step, it won't take off properly. On wheels, it's an expanded range. A couple of books, Ed liked this one too. This is kind of the basic float plane primer. If you like reading on the side, How to Fly Floats by Jay Frey. He was involved with floats for years and years. This is a great one. I did more primary float instruction, not always make sure every student had this. And one I like, this is by Renner, the PhD. If you like the physics, everything that goes into the ins and outs, he describes why certain things are the way they are. And it's a fairly thick book, but there's some great information in this.
What's the title on that one, Lonnie?
Say that again.
Title?
This is called Seaplane Operations. And I think he's Canadian. There's a lot of Canadian stuff in here.
What was the author?
His name is Dale DeRemner, R-E-M-E-R. This is one of my favorite seaplane. He has just a ton of experience.
I got a quick question for you. You just said
Go
the
ahead.
CG is much different when you're on floats than it is when you're on wheels. Where do you find that published?
Well, the later float planes actually have a, like say a Cessna 185 or 206. There's actually in a Beaver, a float plane supplement that goes with your regular owner's manual, your POH. Make sure you have that. The older float planes may just have, like a Cessna 172, just a little blurb about the CG envelope. You have to actually draw it up yourself.
All right, thanks.
But the later float planes actually have a whole section on it specific to floats, from the checklist to the CG to everything. And every air taxi at Lakewood will have a whole float plane manual that goes with the pilots.
The weight and balance has the difference between floats and wheels.
Thanks.
But when you walk up to the plane again, how's it sitting on the water, in 180, 185, something like that? There's no point of ever putting the fuel on left or right. If it's properly fueled, you can just leave it on both all summer. But one thing to remember, if you do have a left-right switch like a 206, if you're turning, it never goes to some wheel. So you start doing a step turn, that fuel's gonna slosh to the outside. If you're on the wrong tank, right about the time you lift off, the engine's gonna quit. So always think about if you're on a left and right style float plane like a 206, if you're doing a left-hand step turn, you better have it on the appropriate tank, so the fuel doesn't slosh to the outside. So there are differences, just because you're a whiz pilot with a wheel plane and you put it on close, make sure you practice up and realize it's a completely different airplane. I'm gonna start switching some slides here. So Ed had some slides in here about getting on step, building speed. It's all fairly basic stuff. And you have the different phases, of course, the hump phase, as you get on step, and then unlike wheel planes, takeoff it tends to be one of the critical on every plane, but it's more difficult perhaps than a wheel plane because of the drag of the water. And like you see about everything from Cubs, Beavers, 206s, a lot of Cessnas. This is a 206 here. One thing on your pre-flight, especially if you're a 135 operator, make sure you discuss in your passenger briefing, emergency egress, something like a 206, those double doors in the back will not open with the flaps down. And you always have the flaps down pretty much on every landing, every takeoff, so make sure the passengers know how that works. And the same if you're in a plane with just one door like a Cub, make sure your passenger knows how to get out. If you've ever talked to people that have been upside down in a float plane, it's kind of a panic situation, or if you've ever done the underwater egress training, we used to have to do that with work every year. And in a 5-foot pool with the lights out, they would put you in a little cage and tumble you into the pool. And 50% of the people that take that class would drown if it wasn't for the scuba divers at the bottom of the pool to lift them out. And everybody's watching. You can see they're reaching around doing everything they're supposed to do, where they couldn't find what they thought, or the thing was on the other side versus the side they thought. Your brain kind of goes into this panic mode, and it's real easy to, have trouble. So, wind is much more critical with float planes. You don't have brakes, obviously. It tends to weather vane into the wind. So there's that challenge as well. And where a lot of pilots will get in trouble was on their heavier loads. Float planes just don't have the performance, obviously, as wheel planes on takeoff. A good way to practice that is pull the power back practice some reduced power takeoffs sometimes. And even a better way, it's a little more trouble, is to go ahead and add some weight to the airplane. Either dog food or put some water in the flows right on CG. It's amazing the difference between a heavily loaded Beaver or 206 versus a lightly loaded one, which is like a hot rod. One thing with Google Earth that we've all been using, occasionally we practice a lot of step turns in training, and it's more to develop pilot technique. In the real world, you rarely do a complete circle step turn, but something like a river or an oddly shaped lake, you may do a short step turn. There's this technique of lifting the float up. It's very common because the heavier loads, it reduces the drag. And again, with float plane, when you first start climbing out, you come off at minimum speed. It's always good to really watch your rate of climb. In fact, a rate of climb indicator is almost a must-have in any float plane. And glassy water is, of course, the big gotcha, and it gets experienced pilots, very experienced pilots, as well as new pilots. It's something to be really careful with. Docking is an interesting challenge with float planes. Jack Brown Seaplane Base, who's given more float plane ratings than any other school in the entire country, they pulled all their docks out. They were damaging too many planes. And you get your entire float rating without ever learning to pull up to a dock. But in Alaska, places like Canada, this is Vancouver Harbor, docking is something you need to do. And if you have help, it really it makes it much simpler. But before you pull up a dock, pay attention to the wind, kind of know what the float plane's going to do, which way it's going to turn. Once you kill power, it's going to want to weather vane into the wind. And it's really interesting at Lake Hood. You can sit there for 20 minutes and watch the people that have done it thousands of times versus someone that's done it 10 times. External loads is a whole subject in itself. I think my advice with external loads is talk to someone that's done a bunch of it before you. And you also, you need to have a permit for your plane to fly external loads. And with Google Earth and going to unfamiliar places, places like Rust, if a pilot has never been to a lake before, they have 1,700 waypoints in their GPSs. All the places they've ever been to. Make sure you plan out the distance, how long it's going to take. I mean, the Google Earth is really a nice tool for floating because there's not really a supplement for every lake you're going to, so you can measure pretty much everything, landing distance, takeoff distance. And so the typical rule of thumb that I like to use, if there are trees on a lake, you need to be off at half the distance. And that'll give you a little extra margin. And if you're not off, then it's time to go aboard and maybe try the other way. A lot of times, the wind is just light, 5 to 10 knots, you can't tell. The water's smooth. But you try it the other way, you're off immediately. So it's really hard to detect a 5 or 10 knot wind without a wind sign. And glassy water doesn't have to be glassy, it can be just kind of glacial water. And your depth perception, doesn't matter how good your eyesight is compromised. So really be careful. Anytime you feel like you don't have good depth perception, or this looks like Axonite Lake, it's a, if I'm correct, by Denali, it used to be a glacier, it melted back, and now the Park Service allows floatplanes in there. It's right off the Ruth Glacier. But you come in there with these steep rocky hillsides, and everything looks out of perspective, and you really have to be careful. Use your best glassy water technique. So just some of the gotchas there, and like every type of flying, practice, talk to We don't all have the luxury of sitting around at Rust with 20 pilots all comparing notes and what works, what doesn't. But for your type of plane, there's a lot of experienced pilots out there. Say you're in crosswind with a beaver on floats, if you put the flaps down, it's really tough to control that airplane, especially on the river. And nobody likes taking off without flaps, but sometimes you have to. You can't stay straight. Ed had a little thing in here where he's talking about if your floats seem to be sinking. I saw this happen at Cat 5 one time with 50 float plane pilots watching. The guy pulled off the shore with his 185, and the more the bow started diving in the water, the more power he added. The worse it got. Finally, people yelled at him, pull the power, pull the power. It popped back up, he made it to the beach. It just repaired his float. The day before, didn't bother checking, it was completely filled to the water line. So he had so much weight on that side, and just only 2 right-hand turns. And you always expect the plane to go left with the torque. And he just kept adding power, because it thought it was going under, and it just kept going farther and farther down, until the whole front of the float was underwater. But he pulled the power, and it popped back up, and he was able to get to shore. So things like that, if you think you have leaky floats, find out what's going on, make sure your pump is working, always prime your pump in the lake. A lot of these pumps, use them all summer. And you think, oh, my floats are great today. Well, the pump's not working. Stick it in the lake, make sure it's working. Make sure each one of those hoses that goes to the bottom of the float is actually pumping the water out. Because they can slip and they're 3-4 inches off the bottom. Every gallon of water is another 10 pounds. And it's real easy to have an extra couple 100 pounds in your plane. Ed has this quote he likes to throw out. The 2 most important things a pilot needs to know are, does anybody know the answer? The next 2 things. Any questions or comments?
Thank you.
Thanks.